indeed. How does it work? Welcome to the video. You're seeing a diagram on the screen, 9 parts. I'm delivering this solution with 3 pieces of hardware, and the software is written in C++. Let's dive in. We'll have one main device, the ESP32, that will be plugged into the bike, and that will power the other 2 devices we'll be using in this solution. The heavy lifting will be done by an ultrasonic sensor. This sensor will send out a ping to an object. That pulse will bounce back off the object, called the echo. I'll have to write some code to calculate the time difference between that ping and echo response. Again, in code, I use the speed of sound calculation to determine the distance between the sensor and the object that it's just pinged off. I then compare that distance against a set of predetermined thresholds of distance. I then send a signal from the main ESP32 to an 8x8 LED matrix to light up or turn off certain lights. Then, simply put, the closer you are, the more lights you get. And in theory, as long as all lights aren't lit up, it should be safe to reverse. You might be wondering what an ESP32 is. It's a small computer chip. It's used to build solutions just like this. It can have Wi-Fi and Bluetooth and other things built in. It's a microcontroller, so it can read and write things, read sensors and control motors, etc. That's enough waffling. Let's get on to the montage. You can see my early distance testing was going well. Floorboards creak where the old moves go. Strobe cuts the dark, heat hangs thick. Glow of the bar, vintage trick. Fingers tap the rail, hips start to sway. Memories wake up, won't fade away. Spin that record, let the bassline thud. 80s nights, we're back where we stood. Glitter on the shoes. The ground was interfering so much with the sensor. Disco still keeping our vow. Spin that record, let the synth take flight. Lost in the beat, we own the night. No new paths to chase, just this old sound. Our 80s disco still holding us down. You've made it to the juicy bit. I don't know what you're expecting, but you're about to watch me go backwards and forwards a couple of times. Right now, we're going backwards. If you look at the image on the screen, you can see that the LED matrix is slowly filling up as I'm reversing. There's going to be a small amount of variance because the sensor is mounted to my indicator, which isn't directly at the back of my bike, but it works quite well. We move to the second example where I'm scooting forward. So slowly but surely, that LED matrix is losing light as we go over those certain thresholds between 0 and 2 meters. My final thoughts after finishing this project. Well, after refactoring some of the AI slop that I used at the start just to get a grasp of the solution as a whole, I'm pretty proud of the code, and it's pretty bomb-proof as a proof of concept. To enhance this solution further, to make it viable for the open road, well, you'd want to solder it together. Currently it's a bit flimsy. You'd want to make it waterproof somehow. You'd probably want to incorporate some kind of sound, like a simple buzzer. And for the fun of it, wouldn't you want a front sensor as well? Thank you for making it this far. I want to hear about your motorcycle tech ideas that I could do for the next videos. If you could subscribe, that would be great. And I've linked my code repo at the bottom with instructions of how you can create this for yourself at home. That's all for now.
Code and Corners, Code and Corners, Code and Corners.